This video is about alcohol and carboxylic acid homologous series. This is the general formula for alcohols. For example, if I have methanol, so 1 carbon, and therefore C is 1 here, H is 2N plus 1, so H is 1 times 2 plus 1, that's 3, and OH. So that's what we have here. C, 3 hydrogens, and then OH. There we have the methanol here. Next, ethanol, that's an alcohol with 2 carbons. That's a very common alcohol in alcoholic drinks. That is an alcohol with 2 carbons. I'm going to draw it here. This is ethanol. Next, we would have propan 1-ol and propan 2-ol. Why don't we have ethane 1-ol and ethane 2-ol? The reason is because there's just 2 carbons. Wherever the OH is, that would be carbon number 1. So if I were to put the OH here, this would be carbon number 1. So there is no ethane 2-ol. So both propan 1-ol and propan 2-ol has 3 carbons, but the position of the OH is different. Propan 1-ol is when the OH is on the first or terminal carbon. You can put it at the most left or most right, that is fine. And therefore this is carbon number 1, 2, and 3. So that's propan 1-ol. Propan 2-ol, that would mean that the OH is in the middle carbon. And I'm drawing it in full structure, so I show all the bonds. This is propan 2-ol. We learned 2 ways to make ethanol here. One is by fermentation, that's the biological way. This is an exothermic reaction. And the other way is by hydration of ethene. This is the chemical way. It's reversible and exothermic. So hydration of ethene looks like this. We did it here. In the fermentation method, enzyme is a catalyst, a biological catalyst, and this will catalyze the glucose to become ethanol and carbon dioxide. Heat or energy is released. That's why we know that it's exothermic. In hydration of ethene, although it's exothermic, so by right, low temperature would favor this reaction, but actually they use a very high temperature, 570 degrees Celsius, in order to increase the rate of reaction. So that's a compromise. So I've showed you this equation once before. I'm going to show you again. Water plus ethene, and at a very high temperature, 570 degrees Celsius, with phosphoric acid as the catalyst. And this should be at 60 to 70 atm in pressure. Imagine this side of the water goes to one of the carbon, and this H goes to the other carbon because it was unsaturated. So now it is saturated. I'm just going to copy the H from before and put in this OH here and put in a H. I'll put the H here and the OH here. Either side works. Ethanol is a pretty good fuel. So we can write the combustion equation here. And ethanol is good as a fuel because it has less impact on carbon dioxide levels compared to fossil fuels. So let's balance this. There's 2 carbons here, so 2 moles of carbon dioxide and water. And there's 1, 2, 3, 4, 5, 6. So 3 moles of water here. And since there's 3 oxygen, 4 oxygen, so 7, 1 is here, so 3 oxygen, 3 moles of oxygen gas there, and plus heat energy. Alcohols, unlike alkanes like methane, ethane, they're gas, but alcohols, they're liquid. Even in ethanol, it's already a liquid with 2 carbons compared to an alkane with 2 carbons that is still in a gas form. The reason is because alcohols have stronger intermolecular forces. Next, carboxylic acids. So the functional group in a carboxylic acid is its COOH. So one with just 1 carbon, like methanoic acid, it would only have this carbon then. So HCOOH. Ethanoic acid would have 2 carbons. So start with a CH3. And again, COOH. Next, propanoic acid. Therefore, 3 carbons, and one of which is a COOH. We'll fill out the H here. And if you count the carbons, hydrogens, and oxygens here, you'll see that it will tally this CN, H2N, and O2. So when ethanol is left standing in air, bacteria will bring about its oxidation, and this produces ethanoic acid. That is called acid fermentation. And that's how we make vinegar for cooking. And there's another way to do this to make ethanoic acid here. So the other way, of course, is the chemical way. We use oxidizing agents. So from ethanol, if we were to oxidize it with KMnO4, this is purple color, it will decolorize and become colorless, this side, because it has been oxidized and the KMnO4 has been reduced. So KMnO4 is no longer there, so the purple color will decolorize and we will obtain carboxylic acid. Since carboxylic acid is a weak acid, it will turn blue litmus to red. So this is one way to test that it's an acid. A carboxylic acid also reacts with metals, bases, and carbonates. I'll show one example for each of that. So if it reacts with a metal, say Na, this might be very vigorous. It's going to form salt. And so these two exchange place. So we get half mole of H2 gas. If it reacts with a base, such as NaOH, we'll get the same salt and water. So isn't this just acid plus base equals to salt and water? So you've seen that before under the acid-base chapter. And the last one with a carbonate. So carbonate is officially a good test for acids. So you'll get the same salt again. You'll get water and some gas. Carbon dioxide gas will be liberated because of this carbonate.